Hey guys, it's Tutor for Math here, and today I have another video. I'm going to be teaching section 1-3 from this geometry textbook right over here. Please like this video and subscribe, and I hope this video was helpful, and let's get started. Today we're going to be learning segments, rays, and distance. So what is the segment? Or you can also call it a line segment. A segment consists of endpoints, and those endpoints are basically a line but has no arrows. What I mean by this is, for example, if you have a line and has 2 points, you can call these 2 points without this part and this part, that's a line segment. And these are endpoints because they're at the end and they're points, which is very convenient. And if we scroll down, let's erase this. So we're going to also be learning about array. So a line will be written with arrows, like I showed you in my last video. And a line segment will be written is just a line without no arrows. You don't need to draw the dots or anything. And a line segment stops at exactly 2 points and never continues on. So it's a specific amount. And then there's something called array. Array is kind of a line segment and a line mixed together. So what I mean by this is, if you look at a line, it goes like this. And if you look at a line segment, it's this. An array is one dot and another arrow. So what this means is it has one endpoint and one arrow. So one side it stops and another side it goes on forever. That's called array. And the array is written like this. You don't really need to add that dot over there. You can just write it like A, B, and then arrow like that. So you don't really need to draw the dot here. But writing array might be confusing at first because you can draw the rays in different ways. So what I mean by this is, if you draw an array like this, for example, it's A, B. A, B. You obviously write it A, B. And remember, you can never write your arrow this way. Like, you can never write it like this. That's completely wrong. There is no such thing as that in geometry. So, if you have an array like this, and let's write AB, BA, you can write it like this, which is the same. These two rays are the same. But what if these two letters were switched? What I mean by this is, what if A was here and B was there? This wouldn't be the correct notation for this, or like the correct way to write it. What you need to write is B, A, line, ray, B, A. This is because if you look at it, B is the endpoint. So when you write it, you have B at the end of the ray. So imagine there's a dot over here. So B is near the endpoint. And point A is near the arrow right over here. So A is right near the arrow over here when you're writing it. That's the way I remember it. Let's move on. So here's a question on what we discussed before. Is ray BA and ray AB the same ray? And if you know how to answer this, that's really good because it will be very useful. Ray BA and ray AB, I'm telling you right now, is not the same ray. Because if you draw it, B would be the endpoint, but here A would be the endpoint. So let's see. So if we draw this out, BA does contain the same points, but they're drawn in a different way. Here, B is the endpoint, and here A is the endpoint. Here, point A is facing the arrow. Here, point B is facing the arrow. The only difference is the letters are switched around. So let's move on. So there's something called opposite rays. So if you don't know what that is, opposite rays are two rays that are connected by the endpoint. So what I mean by this is, if there's one ray that goes like this way, and another ray that goes this way, they're two endpoints. And opposite rays are two rays that come together at an endpoint. Also, you can think of it as a line with one dot in the middle, or like one dot anywhere. So if they ask you what are the pairs of opposite rays, you can say ray CB is opposite to ray CA. Remember, C is the endpoint for this ray and also this ray. You probably don't remember this, but in the beginning of the video, I told you can write it as a line segment. Same thing over here. For opposite rays, you can write line AB, but that's not called a ray. But if you write ray CB, that makes more sense. You won't really be needing this, but it will be useful when you're trying to figure out how many segments are there in this figure or how many lines are there in this figure. It would be helpful. So the next exercise I have for you guys is draw and label 4 points so that 3 of them are collinear, but all 4 of them are not collinear or non-collinear. Draw and name one segment and a pair of opposite rays. So if you draw it, it would look something like this. Because 3 of them would be collinear. If you watch my last video, it would make sense. Collinear means points that are on the same line and on one line. So point A, point B, and point C are in one line. You can use any letter, but it has to be capital letters. But all 4 of them, if you combine the 4th point, they're not collinear. So only these 3 points are collinear. If you combine one non-collinear point, the entire thing, when you're describing the entire thing you drew, it's automatically non-collinear. I hope that made sense to you guys. And let's see. So one segment can be segment AC, or you can write segment AB, or you can write segment BC. It all makes sense. And a pair of opposite rays are ray BA and ray BC. As you can see over here, B is the endpoint for both of them, like shown in here, and C and A point C and point A are near the two arrows. So they're written right here. And remember, these arrows always face to the right. If you don't know what intersection is, be sure to check out my last video. But here we go. If a line that intersects a plane in exactly what point, you have to draw this figure. I already drew it for you, but pause this video and try to do it on your own. And here it is. And remember, you always have to draw these dots if you're trying to show that these dots are there, but it's not in front of you. Like, it's behind the object, so you draw those dashes. So this would be line L. You can name your line anything you want, but it has to be a lowercase letter. This is plane P, and it's a capital letter, and point Q. And this is the intersection point. Point Q is intersection point between plane P and line L. Now let's move on to the second one. Two planes that intersect in a line. So what this is, I did two examples, but the first one is relating to this question. So if two planes intersect in a line, it means two planes are intersecting. Here are the two figures I drew. You can draw any way you want, but they basically mean the same thing. This right here is intersecting in a line AB. Even though it doesn't have the arrows, it's still considered a line. Don't think of it as a line segment. That's completely wrong. This intersects in a line AB. Now let's continue. So there's something called a postulate. So a postulate is a real fact. It's like a fact for sure. So let's see the definition. So you don't need to prove this. You already accepted this statement. Say 1 + 1 is 2. That's a statement, and it's true. You know it for sure, and it doesn't really need, it has proof, but it's a statement that is accepted. So, our first postulate we're going to learn in this entire geometry textbook is called the ruler postulate. But remember, the names are not always there for the postulate, so you might have to remember word for word, or it's better to learn the concept of it. So you might not have it as a ruler postulate. You have to remember this. And there's something called proofs where you need to know these things. That's why they're there. So the ruler postulate is points in a line that can be matched with 1-to-1 with real numbers, and the real number that corresponds to a point is the coordinate of the point. What I mean by that is, if you have a number line, which you probably learned in elementary school, and there's 0, 1, 2, -1, -2, and so on. And you have the coordinate J, and you have the coordinate K. The coordinate of a specific point is the number that corresponds to that in the number line, or the real numbers. So the coordinate of J is -1. The coordinate of K is 2. Okay, I hope you understand that. There's a second part to this ruler postulate. Let's see what it is. And the second part is the distance. And if you don't know this, distance is written in a different way than a line segment. In a line segment, you write probably like this. That's a B, by the way. Like that. But if you're trying to symbolize the distance between 2 points, it's actually written like this. It doesn't have the line. And the second part is trying to find the distance between 2 points. And that's basically the absolute value of the difference between the coordinates. So what I mean by this is the absolute value of 5, let's say, is 5, if you don't know this. So the absolute value is always the positive of whatever number it is. Even if it's -5, it's 5. That's the way I remember it. So you can subtract any two numbers, 4 from -2 or -2 from 4. But the distance is always a positive number. So that's why you use the absolute value. And the length right here, this is called the length of AB. So the distance between 2 points is written like this. And you have to use the coordinates to find the distance. And if you write it like this, for the distance is completely wrong. So once again, this symbolizes the segment, the name of the segment. This symbolizes the distance between 2 points. Now let's move on. Now, there's a second postulate we're going to learn. It's called the segment addition postulate. So what this is it's kind of really simple. It means if 3 plus 7 is equal to 10. So AB plus BC is equal to AC. So what this is saying is the length of A to B is the distance from A to B plus the distance from B to C is basically the distance from A to C. That's really simple, as you can see. And you can also write in shortcut. I write it like this. Segment. You can add a dot right there. Segment. Addition. The actual symbol. Post. But that's a shorter version of saying postulate. You really don't need to know this, but if B is between A to C, then AB plus BC is equal to AC. Or you can use any of these. You can say if BC plus CD is equal to BD. Remember, it's not line segment. Now there's something called congruent segments. And there's also a symbol for this. What congruent segments are essentially are segments that have the same length. So over here, AC and CD have the same length. As you can see, 3 plus 7 is 10. So this entire thing is 10. The distance is 10. And this entire thing, as it is already given, is 10. So congruent means it's talking about the segments, it's kind of talking about the distance, but not really. You'll see what I mean in a while. And there's a specific symbol for congruency. It is an equal to sign with a squiggle on top. It's not a perfect one, but it still works. Now let's move on. Name a pair of congruent segments from the picture in postulate 2. As I told you, AC is congruent. Segment AC is congruent to segment CD. You can't write the length. The length talks about the specific distance, but this is talking about the segments in general, if that makes sense. So you would write it like this. Segment AC is congruent to segment CD. But if you want to talk about the length, so 10, the distance 10, and the distance 10 over here, you would write AC is equal to CD. There's a difference. Here it's talking about the number, here it's talking about the segment in general. This is talking about in general. What do you see? This is going in more specific and saying, oh, these two are the exact same length. Now let's move on to an example. Given that point A, point B, point C, and point D are collinear points, find BC, or the length or the distance between BC, if the length of AC is equal to 2x plus 4, the length of BC is equal to x, the length of BD is equal to 3x plus 1, and the length of AD is equal to 17. So first I would recommend you first draw a figure. And this is the way you would draw it. As you can see, you draw a number line, you draw the points. I kind of drew it equally, but it doesn't really matter. You would say, since it says find BC, you're trying to find BC right over here. So you would do AC is equal to 2x plus 4, BC is equal to x. That's what we're trying to find. And BD is equal to 3x plus 1. So let's move on. Now, to solve it, you will write an equation. It would be question mark, or what you're trying to find, plus x is equal to 2x plus 4. So what it's saying is this value, which you don't know, plus BC is equal to AC, which is postulate number 2, the segment addition postulate. So you would solve it. You take this x value to this side and get x plus 4 is equal to the length of AB. So then, after you find x plus 4 is equal to the length of AB, you would just plug in that expression. I'm sorry I gave the answer right away. But pretend you didn't see that. Next, to find the length of BC, first what you would do is take AB, the length of AB, plus the length of BD, and you would plug it in. So it would be x plus 4 plus 3x plus 1 equals 17, because that's the entire value. Then you would do 4x, because if you do this, you are combining the like terms, plus 5. You're combining the like terms. And you subtract minus 5 from both sides, and you get 4x equals 12, and then you would divide and get x equals 3. And x now would be the value of BC, and that's what you're trying to find. So BC is equal to 3. I hope that was helpful, and let's move on. There's something called a midpoint of segment. And what that essentially is, if there's a segment, let's say here, pretend that's a dot, and there's a point in the middle. A midpoint, that's the midpoint. The midpoint of segment is a point in the middle, or more specifically, is a point that divides the segment into two congruent parts. So let's see the definition. The point that divides the segment into two congruent segments, which is essentially what I said. Now let's move on. The bisector of a segment. What that is, you really need to know this because what we're going to learn in the next section is mostly about that. The bisector of a segment is basically a ray or anything, but not a point. Like you can have a line, a segment, a ray, or a plane, but not a point. Remember, that's the midpoint that intersects the segment at its midpoint. So you can kind of tell the bisector of a segment cannot be a point, because that would technically be called the midpoint, and a line could intersect it, or pretend that was near the midpoint, or it was on the midpoint, or this is a ray, or a line could intersect it, bisect it, or a plane, which I can't really draw, but it goes through the midpoint like this. We're not going to be really using much of the bisector of a segment, but I would recommend you learn it. And in the next chapter, we're going to learn some things about angles, and there's something called the bisector of an angle. And that is more useful and will show up more on practice problems or tests. I hope this video was helpful, and please like and subscribe, and yeah, that's it.